Hey everyone, and welcome back to The Explainer. Today we're unpacking a truly incredible scope of scientific achievements that have surfaced over just the last 365 days. We've combed through a massive amount of research and distilled it all down into a clear roadmap to show you exactly how our world is changing.
We're standing at this entirely unique point in human history where science fiction is rapidly, and I mean rapidly, becoming science fact. Today's explainer takes us on a pretty gripping ride. We're going to start all the way down at the microscopic, invisible building blocks of life, push right through the digital realm, and accelerate all the way out into deep space. Get ready, because the sheer pace of innovation right now is staggering.
So here is our micro to macro roadmap for today. First, the building blocks of life, then the AI and computing leap, unlocking the quantum realm, energy and Earth innovations, and finally, the new space age.
Section 1, the building blocks of life. Okay, let's dive right into this at the cellular level.
This technology right here is fundamentally redefining medical research. It's called an organ on a chip. So instead of studying cells in a flat, old-school petri dish, researchers are now using these micro-scale systems to actually mimic the real environment of the human body. They take human cells, place them on a tiny computer chip, and use a polymer scaffold that acts just like real human tissue to help those cells grow into 3D structures. It's literally a functioning, living mini organ sitting right there on a microchip. Now, you might be wondering, why does this matter to you and me? Well, this isn't just cool lab tech. It gives us a highly accurate, human-relevant platform for testing drugs and modeling diseases. It's a totally ethical alternative to animal testing. It's super cost-effective, and most importantly, it paves the way for truly personalized medicine. Just imagine a future where your doctor can test out a treatment on a chip modeled perfectly after your own unique biology before you even take a single pill. And speaking of rewriting biology, let's talk about CRISPR-Cas9. You can basically think of this system as a pair of molecular scissors. A specially designed guide molecule hunts down a target, defective DNA strand. Then, an enzyme just snips it right out, allowing a healthy copy of DNA to jump in and replace it. This tech is moving incredibly fast. In fact, researchers from Kashmir University, teaming up with ICAR, recently used this exact CRISPR technology to produce India's very first gene-edited sheep.
Let's see how this builds from engineering biology to engineering the mind and machine. Section 2, the AI and computing leap. The digital landscape has absolutely exploded lately. Take the launch of BharatGen, for example, India's very first indigenously developed AI multimodal language model. But, new tech brings new rules, right? Like the US enacting the Take It Down Act to aggressively tackle the spread of deepfakes. But perhaps the wildest update here comes from Stanford. They've developed a brain-computer interface that translates neural signals into text, but it now requires you to literally think a specific mental password before it'll decode your thoughts. We're talking about privacy at the neural level. But adopting all this AI globally brings up some pretty complex economic realities. Have you ever heard of the Jevons paradox? It tells us that as tech makes a resource cheaper and more efficient, like computing power, for instance, it actually leads to a massive increase in demand for it, not a decrease. On the flip side, we have the Solow paradox. That one warns us that just because we're heavily using advanced tech like AI, it doesn't mean we're going to see an instant spike in overall economic productivity. Integrating these tools into the messy real world is, well, complicated. Which perfectly sets the stage for the raw computational power we need to solve those exact complexities. Section 3, unlocking the quantum realm. So I want you to think about this question for a second. What actually makes quantum tech fundamentally different from the phone or computer you're watching this explainer on right now? Okay, so in standard computing, data is processed in bits, and those are strictly either a 0 or a 1. But in quantum mechanics, we use qubits. Thanks to this wild principle called superposition, a quantum particle can actually exist in multiple states at the exact same time until we measure it. So a qubit isn't just 0 or 1, it's effectively both simultaneously. This allows quantum systems to process an astronomical number of possibilities all at once, unlocking computing power that is literally world-changing. And this brilliantly illustrates another absolutely mind-bending concept, quantum tunneling. Think of it like this. If a kid throws a ball at a solid brick wall, classical physics says it bounces right back, obviously. But in the quantum realm, particles can miraculously pass right through solid barriers. You'd be pretty shocked if that ball suddenly just phased through the wall and appeared on the other side, right?
Well, the 2025 Nobel Prize in Physics was just awarded to researchers who proved that these strange microscopic quantum effects like tunneling can actually be observed in macroscopic systems, meaning everyday electronic circuits. All right, let's zoom way out from the subatomic level to the macro systems shaping our entire planet. Section 4, Energy and Earth Innovations. At the absolute heart of our energy future is the quest to basically replicate the sun. Let's contrast our current nuclear technology, fission, with the holy grail of clean energy, fusion. Fission splits heavy atoms apart, which creates radioactive waste that hangs around for millions of years. But fusion? That's what happens naturally in stars. It slams two light hydrogen atoms together. It generates 4 times more energy per kilogram of fuel, and it creates 0 long-lived radioactive waste. Right now, the world's biggest nuclear fusion project, the ITER Tokamak reactor over in France, is being actively built to harness this, and India is actually manufacturing the massive cryostat chamber that houses the whole thing. Back down on Earth, the way we physically build things is completely transforming through additive manufacturing, what we all know as 3D printing. The applications are everywhere now, from bioprinting those organs on a chip we talked about earlier to reconstructing ancient fossils. But it's the sheer speed and scale that is just staggering today. Just recently, Japan achieved this incredible feat where they completely 3D printed a functional train station in just 6 hours. No way, right? 6 hours. And how are we going to travel between those printed stations? Enter the Hyperloop. By putting a vehicle inside a low-pressure tube and using magnetic levitation driven by a linear induction motor, we practically eliminate friction and air resistance entirely. Maharashtra recently signed a deal with an IIT Madras startup to propose exactly this kind of system connecting Navi Mumbai to the Vadhavan port. They're aiming to completely redefine ultra-fast, eco-friendly transit for us. But hey, innovation isn't just happening on land. We're diving deep, too. India's Deep Ocean mission is really pushing the boundaries of extreme exploration to unlock what's called the blue economy. The Samudriyan mission is set to launch by 2026, sending humans deep into the ocean to sustainably explore for critical minerals. And we're already making history. Recently, 2 Indian aquanauts dived past 5,000 meters into the Atlantic Ocean. That puts India among a very select group of nations capable of that kind of extreme deep-sea exploration. Now, from the crushing pressures of the ocean floor, let's look upwards. Section 5, the new space age. The milestones we are passing in space right now are just breathtaking. We've got the FRAMD-2 mission using a SpaceX Dragon spacecraft, which will be the very first human spaceflight to cruise directly over Earth's polar regions. Meanwhile, way up in the high altitudes of India, the extreme UV-heavy saline permafrost of the Tsokar Valley is serving as a Mars analog site. Astrobiologists are out there actively preparing for long-term survival on other planets. And perhaps most excitingly, we're designing completely new ways to travel our solar system. Sunbird, a rocket powered by dual direct nuclear fusion drive technology, is currently in development. Its goal? Propelling spacecraft all the way to Pluto in just 4 years. Which brings us to the end of today's explainer. We've seen how science is accelerating across literally every imaginable scale. So I want to leave you with this. From molecular scissors rewriting our own DNA, to having mental brain-computer passwords, all the way to nuclear fusion rockets destined for Pluto, which of these breakthroughs do you think will most radically redefine your tomorrow? Really think about it. Stay curious, keep learning, and thank you so much for joining me today.